Okay, so this is going to be Python system setting location and rotation. So just following off on the example sim, Python sim.json that we created in an earlier video, we'll go ahead and talk about the second system that we are working on, that we worked on for an example. So right above in the first few lines, this is just a note to tell you what is available inside of this example here. So really how to get entity references, how to set the location of an entity relative to another, propagating an attitude quaternion, which is nice and built in here for you guys. And of course, also setting the rotation of an entity inside of a simulation. Of course, just following on from the earlier video, line 7 through 15 is just to, don't mess with that. That is just for your ability to join a simulation and to access Space Team's uh, um, module. And then down here is, of course, your imports and the definitions for functions for your log screen and on-screen alerts.
Yep. And there's another one here that's propagating your quaternion. So you can see writing a new function here is the same as in any kind of Python version. You still define everything. You have access to all the same types. Basically, you can use NumPy within it, whatever libraries you want. And yeah, this one, for example, just takes a quaternion, a rotation rate, that's our omega, is the angular velocity, which is a vector, and then a time step, and it gives you the next quaternion basically at the next time step, like a dt time later. This is the formula for it. This is how you do it. Built in. There we go. Yeah. So let's go into the first section of this actual tutorial.
Yep. So section 1 here, we're going to talk a little bit about entity references. So we've talked about how entities can communicate with each other inside of an earlier video and how you can tag and set in the refs. But how do we actually access those parameters? How do we get these entity references? This first section kind of tells you how to do that. So this right here in line 77 and line 78 of this Python script shows you, okay, how do I get an entity reference from the system? So sc.getThisSystem really gets a reference to the system inside the simulation config, and then you get a parameter of type entity ref, and then say I want to get the entity2 in this case. So the name tag entity2 is used as my key, and then here it's just to give you the implicit cast of saying, okay, this variable is of type sc.entity. And we'll go ahead and jump right back over to the example Python sim.json, and we'll scroll up to the system itself, and you can see entity2 key with the entity record.
Collapse that system and open up the correct one.
Oh, yep. Let's do that. Yep, there it is.
That's the
there it is.
That's the correct system. They look very similar. In this case, it's just the name of it has changed, and we're referencing a completely different Python script in this case.
Yep.
But turns out the params are all the same.
Yep. So here you can see entity2 is of a type variable of entity ref. So you'd be typing in the name entity2 for what you're trying to search. And then inside of that, you'll be able to get the entity ref of entity2 from here. So when you go back over there, I want to use this entity2 reference system from my system and set some positions and rotations for my object. So we'll go stepping into the while loop here that we talked about earlier in an earlier video. First off, I want to get all the entities that have a reference to my system. In this case,
in this case, just be careful with this. Be very, very careful. I want to draw attention to this here, especially because if you put your system on multiple entities, like you might want to put, say, a propagator on everything in your sim, for example. You might have a bunch of spacecraft flying around. If you do entities equals get all entities, that will be every single entity that has your system on it, right? You have the same system on multiple entities. And this will get all of them. So when you do something and you're thinking, oh, well, this is only going to be entity one, it might not be. So be very careful with that, because in this case, yeah, it's just entity one, it's not entity two. But if you were doing this on entity two as well, that might break some things in the current implementation.
So here I grab entity2 reference from the system, which I want to specifically grab. And here I'm doing entities.get sc entities just to grab all of them. Of course, Alex said if you had multiple ones that are using the same ones, you're going to get all the entities and you're going to move through them. Inside these next couple lines in line 89, I've defined this DT just for the cycling loop, and for propagating that out to quaternion. This is also going to be, that cycle sleep time, which we've seen down below with time not sleep. It's just the exact same thing. All I did was set it into a variable instead of, and this is the same thing as what we saw in an earlier video. And then, of course, getting into section 2 here, which is really setting the location and rotation of an entity. So first off, I've gone ahead and looped through all the entities here. And what I do, because of the fact that there's only one entity that's using the system, which is entity one, sorry. All I'm doing is getting the location of entity one when I loop through the for entity and entities. And then I grab my location inside of the second entity's resonant frame. So the resonant frame is essentially, the reference frame that's attached, or the body reference frame that's attached to said entity. So you have, let's say you had an entity 3, entity 4, whatever, you can get its resonant frame. And really, whenever you're doing a get location function and you're getting that resonant frame, you're getting your location relative to other entity. So hopefully that makes sense. And of course, you'll pull out current entity location there. Next, the next line here is really how we set the location. So all we're doing here is taking that current location and I'm adding 0.0005 in its I think Y direction there. And it's an NP array, so we just add those two together. And all I'm doing is just basically moving it in the Y axis every second.
And there'll be documentation on what all the units are for everything, but in this case, we're operating in meters since we're doing location.
Yep. And here as well, you also have to, when you're calling the set location function, you have to say in what reference frame am I setting this location to? So I take the current location inside of my entity 2 reference frame. So I want to take it, I want to add and move the location of my entity 1 inside of the frame of entity 2. So this is what we're doing here. We notify entity 2 reference from the system, and then we get its resonant frame. So then we're setting location relative to it. Next is a little bit more complicated, but this is just to set a rotation. For those of you who are familiar with quaternion dynamics, this is just really to propagate a quaternion with angular velocity, and then we pretty much transform our current rotation by a little bit. And really, what you're going to get in effect here is movement of rotation of the object at the same time. Mm-hmm. So inside of line 104 to 106 right here, what I'm doing is doing from the entity get rotation quaternion. And then I have to also specify, of course, what frame it's in. In this case, I'm getting it in entity 2's reference frames from the system, and I use that. And then I specify an angular velocity. In this case, I want to go 0.3 radians a second. And so what I do with that is then I go ahead and set a rotation quaternion, and I run that propagate quaternion function that you see earlier. I pass in my current orientation or attitude of my object. I plug in an angular velocity and of course delta time as well. And then that rotates that sets the rotation of the entity. And so you're going to see this rotating effect.
And real quick note here, this propagate quaternion function is getting passed directly into set rotation. You might think, well, a quaternion is just a 4 vector, right? So you just pass in a NumPy array. No, you need to pass in a tuple. So when you get your NumPy array out of here, you need to wrap it in a little tuple over here because that's the type that it expects.
Right.
So just be careful with that. Locations are set as NumPy arrays. Yep. Rotations are set as tuples of 4 values.
Yep. Make sure when you're passing a quaternion that it is normalized as well. You want to make sure by really looking at line 70 here inside the propagate quaternion function, you got to normalize your quaternion after you rotate it because you might break the unit norm constraint mathematically.
Exactly. Yeah. So that's about it for this. That's about it for this system.
Yeah, that's it for the system. But let's go ahead and
let's turn the system on. Currently, it's off. It's false.
So we'll set this thing to true.
Yeah, we'll set it to true. Do you want to keep the other system true as well?
Yeah, I'll keep true. Doesn't matter.
Okay. Yeah, we can keep multiple systems on as well. So that's what we'll do here. And there's no recompile required. We'll just run the sim again. And you can see immediately that entity one right there, the smaller rock, starts to rotate and translate with respect to entity two, which is the bigger rock.
Yep.
So that is how you set basic location rotation params on entities and how you access entity references.